wanted to show you a program that I'm working on and wanted you guys to follow along as I coded it. It's a very simple program, and but it's meant to teach you today, teach you about today's lesson, operators. I realized I didn't really go much over operators, and I just wanted to introduce you to the different C++ operators out there. There are 5 of them. Well, there are actually more than 5, but today we'll concentrate on 5 basic ones. These are the assignment operators. So let me just show you what they are, and you guys can follow along. So this is the addition operator. The addition operator, and I'm going to put it after the hyphen, is the plus sign. So let's bold that because I don't want to make it look like it's a hyphen plus. I mean the I'm going to put it after the colon. I don't want to make it look like it's a colon plus. And then the subtraction operator. Subtraction operator is a minus sign. And then a division operator is simply a forward slash. And multiplication operator is an asterisk. So let's bold that asterisk over there. Okay. There's one more operator, well, 2 more actually that I want you guys to know for today's lesson, and that is the modulus or remainder operator, which is the percent sign. And then I also want you to know about a basic operator that we've already used, the assignment operator. Which is the equal sign. Okay, so the last one, assignment operator, don't get it confused with something I'll teach you about with the future. Two equal signs together is actually an equality operator, and I will talk about tests for equality later in a separate video. But these are the operators that we use today. They're not the only operators available in C++, but these are the main ones, the assignment operators. Okay, so addition operator conducts a sum of 2 different variables. Subtraction conducts the sum of not the sum, the difference of 2 different variables. Division is the quotient of 2 different variables. Multiplication is the product of 2 different variables. And modulus is a special one. It actually gives a remainder. So let's say I did 5 modulus 3. It would actually give me back 2 because 5 remainder 3 is 2. When you divide 5 by 3, you have 2. It goes in 1 time, and then there are 2 remaining. How to explain it? There's so 3 goes in to 5 1 2/3 times, and essentially the modulus essentially takes that remaining 2/3 and gives us back the 2 because 3 goes in one time, but it doesn't go in perfectly, and there are 2 remaining, 2 left over. So that's what the modulus function does. It gives us a remainder. Assignment operator is simple. We've been using it for a while. We just set a variable equal to a value or something like that. Okay, so let's get a magnifier here. If I could just, there we go. Alright, so here we have a simple program that I wanted to show you, and here is double x and double y, two variables, double x and y, and then we have integers a and b. So by the way, this is the same format of a file that we have. We have include iostream using namespace std int main, and yeah. So we also have two integers a and b, and then I've assigned values. X equals 2.5, y equals 3.0, a equals 4, and b equals 7. Now you want to be careful. Here I wanted to show you what happens when we sum them together. Double sum is x plus y, and then integer sum is the two integer values, a plus b, and then the result of an integer summed with a double. So I took the double value b and summed it up with the integer value b and summed it up with the double value x, and then I just experimented and saw what would happen. Okay, so let's take a look at what happens. And by the way, C++ is a little different. There are some exceptions to C++ that don't occur in other languages. That makes sense, of course. It's C++. Double sum is 5.5, so that makes sense. We took x and y, 2.5 plus 3, that's 5.5. The result, and then integer sum is 11. Well, that also makes sense because we have 7 and 4, that's a and b, that's 11. That makes sense. And then the result of the integer summed with a double is 9.5. So I summed 7 with x, or 2.5, and that makes sense because 2.5 plus 7 is 9.5. Alright, so all's well that ends well, right? Well, we have some more operations to do. Okay. Then we're going to do double division is, and we're going to do x over y, 2.5 over 3.0. We're going to put n line. And if I can just change the magnifier settings for a second. Cout double division, okay, we did that, and then integer division is, we want to do, let's say, b over a, or whatever. It doesn't really matter, but, well, actually, let's do b over a. Nah, a over b, because that makes sense. That makes more sense. Okay, and then we put the result of an integer divided by a double is. So we're going to put b over x, b over x, and put inline. So that's our program so far, and let's see how we've done. Okay. So let's look what's going on here. Double division. We've got a little bit of a round off error because that makes sense. Doubles can only hold so much, even though they can hold the range that they can hold is much higher than the integer. Doubles are prone to round off error, and they do take up a lot more memory, so be aware of that. And then the integer over here, shockingly, I got that the integer division is 0. How did that happen? Wait a second, 4 over 7? That can't be 0, right? Actually, what happens is when you're doing when you're doing integer division, it actually rounds off a bit, and if you have something like 4 over 7, it takes the decimal place out of it. So any decimal will just round down to 0. So let's change that. Let's try to redo that let's try to just make one small change and see what happens if we were to divide b over a instead and see what happens. B over a. So that's 7 over 4. Look, so let's see what happens when we divide by 7 over 4. The result, the integer division is 1. So as you can see, in reality, it's going to be 1 point something because 7 over 4, right? It's going to be 4 goes in 1 and something number of times. But what happens is that when we're doing integer division, it truncates that, or it gets rid of the decimal portion, and so all we have left is 1. So remember, during integer division, truncation after the decimal point occurs. Truncation is essentially getting rid of the decimal, getting rid of everything after the decimal point. Truncation is getting rid of everything after the decimal point. Okay. There really isn't anything too special about subtraction or multiplication. Everything that I've stated applies to subtraction and multiplication too. Wait, there's one thing I forgot. Let's check the result of the integer divided by the double. Let's do that. It's 2.8. So when you divide an integer by a double, it immediately casts to a double, and you get 2.8. That makes sense. Okay. So I don't want to waste our time doing multiplication and subtraction because it's gonna have the same results as sum, division, same results as addition, division, essentially. But I wanted to show you how to use the modulus operator, which we've never done before. So I could put a C out over here and then just state division modulus is, and then we're gonna take the two functions, and we're gonna do y mod x. That's the first one that we were gonna do, and then after that we're gonna try x mod y. So let's see the division modulus over here. So 3 mod 2.5. Wait a second. It gives me a breakpoint. You can't use double to do modulus. Wow. Well, yeah, so in C++ you can't use double to do modulus. Let me check that, because in Java, which is pretty similar to C++, you can do that. Double mod in C++. There's a special function for this, for doing modulus on doubles. It's called fmod, and it's included in the math class. However, we're not going over to that today, so just be mindful that the regular modulus operator creates an error. So don't do double modulus. We can comment this out. There you go. We commented out. See out, and then we're going to be like integer modulus is well, for integer modulus, we're going to try two different things. We're going to do 7 mod 4 first, or b mod a, b mod a, integer modulus is 3. Well, that makes sense, because when you do 7 modulus 4, you have 3 left over. That makes sense, because when you divide 4 into 7, you have 3 left over. That's essentially what modulus is. It gives back the remainder. But let's try 4 mod 7, or a mod b. A mod b. Okay, so here I get that 4 mod 7, or a mod b, is 4. How is that possible, you're going to ask? Because when you divide 4 by 7, what happens is it rounds off to 0. So when you essentially, the rule is modulus gives back remainder. In a mod b, if a is less than b, a is returned. A being a variable. So let's say we did 4 mod 7 like we did just recently, it would return a 4, because a, which is 4, is less than 7, which is b. So yeah, remember that. When you're doing modulus, if the first value is less than the second value, all that's going to be returned is the first value. Okay, so a word before we go. Now, I'll tell you this. In other languages, such as Java, this isn't allowed. But apparently in C++, it is. In Java or C++, you can assign an integer, say int x equals 9, to a double y equals x. But what you can't do is so this you can do. Can. But what you can't do in Java that you can do in C++ is create a double variable, double x equals 9.0, and then int y equals x. Let's test that out. Let's just test that out for a second and see what happens in C++. From my understanding, you can actually get away with it, but there can be significant bugs that come out of that. So let's just test that out. Let's try double x equals 9.0 int y equals x system out println. Okay, I'm thinking Java. As you can probably tell, I have been so used to Java for the last few years, despite C++ being my first language, that I often confuse both of them. They're actually pretty similar languages, if you think about it, but that doesn't give the excuse to confuse notation with one another. So what we're going to do is the value of y is, and we're just going to print y, and then we're going to do nline. So look what we did here. We assigned a double to an integer. And remember, doubles actually take up more space in memory. So technically you're assigning a double value to a smaller value. And in C++ you can get away with this. In fact, what it's going to show is the value of y is 9, if I'm correct. You see, the value of y is 9. So what it did was it truncated the point 0. So if I were to say make this 9.3, the value of y is still 9. But you still don't want to do this. This is a very bad practice. And that is why I'm saying you can't assign a double to an integer, even though you can get away with it in C++. You can't do that in Java, but you can get away with it in C++. You should think of it as you can't, because this can lead to potential round-off errors. 9.3, and you truncate it to 9, that's 0.3 off. And just to let you know, there have been so many bugs because of miscalculations such as that. And there was even a rocket in like the 90s that killed several people because of that kind of miscalculation. So imagine how precise you have to be when it comes to programming. Anyways, sorry for the lecturing. Thank you very much on this for participating in this C++ tutorial with me on operators, and talk to you next time. Peace.